Hello, this is William from Visual Components. In this video about the Works library, I'm going to talk about turnaround time and provide a simple demonstration on how you can record the amount of time it takes for a production or process to generate an output, in this case a component. So let's get started by creating a basic layout. In the ECAD tab, I collapse the view. I'll go to the Collections drop-down menu here, expand Web Catalog by type, scroll down, and then click Works. Make sure you're using the latest version of the Works library. From here, I'll drag a Works task control into the 3D world, and I'll add a Works process component. I can now add and connect a conveyor to this component here. So I'll go back to the ECAD tab. In the Collections drop-down menu, I'll scroll up and click Conveyors. Let's add a basic conveyor, so I'll drag and drop this conveyor here into the 3D world. I'll zoom in to strike, and then I'll adjust my view. And with PNP, I'll plug and play the conveyor to the Works process component. Now let's go and use the same set of components again. So I'll click Select. I'll select both of those components. I'll right click in the 3D world and click Copy. I'll right click again and click Paste. I'll click PNP and connect this set of components to the other components. Let's do that again. So I'll right click in the 3D world, click Paste, click PNP, and connect the components. Now, before you start generating the turnaround time data, you need to add one more component from the Works library. So go back to the ECAD tab. In the Collections drop-down menu, I'll scroll down, click Works, and you need to find this component, TAT output. This component is responsible for collecting all of that turnaround time data and generating it into a report or a readable format for you. So I'll drag and drop this component into the 3D world, and you need to add it to the end of your process or production line. So in this case, I'll connect it to the end of the conveyor line here. What we can do now is go ahead and create a product at this location here, move it along the path, run a process, change its product ID, and then move it to the end of the conveyor line. So I'll go back to the ECAD tab. In the Collections drop-down menu, let's click Products in Containers. And let's scroll down and find a product. Let's use cylinder. So I'll drag and drop this component to the start of the conveyor line, and let's center the view and zoom in just a bit. And let's go and get this component's name. So let's go to the Param tab, copy its name of cylinder. I'll go to the Works process component here, and I'll make a create task. So I'll go and paste in that name. And instead of using the default product ID of cylinder, let's change the ID to be capital AAA, so 3 A's. I'll click Create Task, and then I'll transport out products that have that product ID of AAA. So transport out, list of product IDs of AAA, and create the task. So now when I run this simulation, the cylinder is created and it exits the work process component. Now notice when I select this component, it's actually stamped with turnaround time properties, which you can see over here. So they start with TAT underscore, and they're followed by the component's product ID number, the location it was at, and what happened. So in this case, the component was created and then it was out at the same time, which makes sense because I really didn't do anything here. So what I can do is I can go over to the other Works process component, and I can run a process that takes up a certain amount of time, change the component's product ID, and then move it along the path. Now, to make things easier, I can refer to a global list of product IDs and process times. To do that, go ahead and select the Works task control component in your layout, and notice in the Param tab it has a subtab for global IDs and global times. In global times, if a product or component has a matching product ID here in this list, it will run for the matching time. So I'll go and add the product ID of AAA, followed by a colon with a runtime of, let's do 4 seconds. So I'll type in 4.0 for a real value time. I'll click Close, and for changing the product ID, I'll go to the Global ID subtab here, and we have IDs for 111 through 333, so let's go and add AAA to the list, followed by a colon, and let's change the product ID to BBB. So if a component arrives with a product ID of AAA, I'm going to change the ID to BBB. Let's close this, go back to the Works process component here, and what we need to do first is transport in the cylinders that have a product ID of AAA. I'll create the task. I'll then go ahead and call a global process and notice there's very little setup here. I just create the task. I'll then use a global ID task, and that will automatically check the global list for that product ID and change its ID. So I'll create that task as well. And to make sure we have everything set up properly, I'll do a transport out task for a product ID of BBB. So if the component doesn't have that product ID of BBB, it's going to stay there in the component. So I'll create the task, I'll reset the simulation, and run it again. So this cylinder is moving on. It goes into the works process component, and it exits out. And notice it also has a new product ID of BBB, and we have more turnaround time properties. So we know that it went into this station at this time, and it went out at this time with a different product ID. So it looks like it was there for about 4 seconds. Great. Let's go all the way down to the other works process component. And we could do something simple here just by transporting out the component when it arrives. But let's actually change some of the properties of a contained component here. So what we need to do is first transport in the component so we can manipulate it. So we'll transport in BBB, or you could do any if you want. So actually we'll just go ahead and do that. I'll get rid of this. I'll create the task, and then I'll create a new task to change the material of a product. So I'll change the product material. For if it matches BBB, I'll change it to red, which is fine. And then for the product property, let's go and change BBB's length. So let's find out what properties this guy has here. So it has a cylinder height of 100 and a radius of 50. Let's increase the radius just a bit. So I'll go back to the works process component here, and I'll change that cylinder radius to be 200. I'll create the task, and then let's go ahead and transport out the component. And instead of using a product ID, I'll just use the all checkbox here to transport out everything. So I'll create the task, reset, run the simulation again, wait till it gets there, and boom, we changed that product. So if we select it, still has the same product ID, but we also have new turnaround time properties that were stamped. So at work process 3, it went in at this time and exited at this time because we really didn't do that much to it. Alright, so now if we go all the way down to our conveyor line, when the components arrive at the sensor of the TAT output component here, it's going to go ahead and collect the data. So if I run the simulation, notice that when the component reaches the sensor, that the property here, parts out, changes to 1. So when the next part arrives, it changes to 2. Alright. Now if you wanted to get the detailed data information, you can go to the TAT_output subtab here, and notice you have options for writing the data to a CSV file at a designated full path that you want, and you can also store the information in the component in a notes property here. Before you do that, make sure you set up the time format you want for the turnaround time, and you can't do this really when the simulation is running, so I would advise you to stop the simulation and then click the Write TAT button. I'm not going to open the CSV file, but you can if you want, so I'll click cancel, but you can still look at the data here in the note property. So if I actually make this a bit bigger, I don't know if you can see or not, but the data is actually delimited using a semicolon, but you can change that to a colon if you want. So I'll close this out and reset the simulation. Alright, this concludes the video. If you have any more questions, please feel free to visit our community at community.visualcomponents.net, and as always, have a wonderful day.